Good evening, students.
Good evening, sir.
Good evening.
Today we'll be starting with all the bonds topics. The first topic that we are going to do today is linear programming. Very simple topic, and from there all the other related topics will come. All topics are actually related to one another, and the object is basically the same. That is either trying to find a solution for a maximization or a minimization of a particular problem. Sometimes what happens is, why these topics are included in your syllabus now is because we are having this decision making as a part of strategic cost management. And in that, we have done marginal costing as one of the major decision making topics. And second thing is that practical problems in life are not as simple as what we get to see in margin costing also. And sometimes they are a little bit more complex and more restrictions are there on various activities or various resources. So to find out the optimal solution of a particular problem, we have to make use of quants. To tell you something very frankly, even your strategic financial management, that is SFM, or financial management as a subject, has got varied difficulty levels, or I would say complexity levels. And what you are observing in inter and final CA or CMA as your syllabus of financial management plus SFM put together is hardly about 10% of the subject called financial management, as I always say. And the remaining 90% of the subject of financial management as well as strategic cost management involves a lot of statistics, a lot of quants. And one of them is linear programming and other techniques which we are having. Plus, there are other statistical models which are of a higher level. And that is probably covered in a course which is called as FRM, that is Financial Risk Management. So there you have a lot of stochastic models of statistics and quants, where you are having higher level statistics. Now, when I say statistics, it is not your mean median mode. It is something way above our level of understanding at this particular point. So what we are having in CMA final here as quants is the basic thing which we require to understand the complexity of a problem or the complexity of solving a particular problem. For example, I want to manufacture a particular commodity. So manufacturing a particular commodity, as I told you, if the resources were in abundant supply, that means unlimited resources are there, then there is no problem at all because I can produce as much as the demand is there. So if there is a demand for unlimited demand for my product, then I can produce unlimited quantity of my product. But practically speaking, that is not so because the resources are restricted, resources are limited. And therefore, we have this complex problem. Sometimes one particular factor is limiting, as we have seen in marginal costing. That one factor is limited, one factor is constrained. Whereas all the other factors, we assume that they are abundant in supply. But in practical life, that is not so. I may have a lot of restricting factors or constraints, more than one factor, more than one particular aspect. So in such cases, how to deal with the problems? Earlier in your syllabus, you had in-depth quants, that is linear programming as a topic by itself. We had not only basic problems, but we had how to solve an LPP, different techniques of solving LPP. That was also there in the syllabus. But now, as the syllabus gets more and more diluted, the methods of solving LPP is not there in your syllabus. Only formulating an LPP program is there. So, what you have in LPP is linear programming problem formulation only formulation. As you had in inter CMA, you don't have solution. You don't have to solve an LPP. You have to only arrive at the formation of an LPP. Earlier we had solution of LPP also. That is methods or techniques used for solving that LPP also. But now, as per your new syllabus, that is of 2016, you don't have solving of LPP. You have just formulation of LPP. Okay. So if you look at the past papers, your past papers earlier than 2016 has problems of LPP solving. That is arriving at the basic possible initial basic feasible solution, what we call as IBFS. But as of now, as per your new syllabus designed from 2016 onwards, the formation of LPP is where we stop. Okay. So what is LPP? Linear programming problem. Linear programming problem is a technique which is going to convert a complex relationship of various variables into a linear equation, into a linear form, and we try to solve those particular equations or inequations. What is basically the nature of question that we try to solve over here in all these methods, whether it is linear programming or transportation or assignment, whatever you call it as. The basic thing is that we try to find out what are the resources, what are the limited resources, and we try to form a linear equation or a linear, you can say a linear formation of those variables. And there are three steps involved over here. Basically the objective, first is the objective. You have to know what is the objective function of a linear programming problem. What do you mean by an objective function? There are two things that we try to solve with the help of LPP. Either maximization of a problem or minimization of a problem. For example, if I want to maximize the profits of a business or if I want to maximize the revenue from a business, then I make use of LPP. Or alternatively, if I want to minimize the cost or minimize the losses, then I try to make use of LPP. So LPP is a technique which is used only for maximization or minimization. Okay. So the first step in LPP is rather trying to arrive at the first thing is objective function. What is the objective? But prior to that, that is as per your method of solving. But prior to that, I would say the first step is defining your variables. So in our problem, our first step will be defining the variables. What are the variables which are there in the function and defining them. So for example, materials are given to me and they are said to be limited in supply. So I will say I will have to define a variable for materials. Variables which are used are normally x1, x2, x3, x4. We don't use letters x, y, z or a, b, c. Very rarely we make use of. But LPP, typical LPP problem is with variables with x only. So we call them as x1, x2, x3, x4, x5 like that. So first thing is that I have to define these variables. X1 means what? X2 means what? X3 means what? Second step is objective function. Trying to find out what is the objective function. Is the objective function a maximization function? Or is the objective function a minimization function? Okay, that is the second step for us. Because when we are solving, first step is going to be defining the variable. Second step is finding out what is the objective. Okay, objective function as we call it. Objective function is always denoted by the letter Z. So Z is equal to something. That is the objective function. Then objective function, as I told you, either it is to maximize or to minimize. Third step is find out all the possible values which can be assigned to those variables. That is x1, x2, x3, x4, whatever variables we have defined. Try to find out all possible values that can be assigned to these variables. If you are doing that, then that means you have arrived at IFBC, that is initial feasible basic solution, or IBFS, which is initial basic feasible solution. Okay. After we do that, we see whether those values, when they are substituted in the equations or the inequations that we have got, do they satisfy them? If the answer is yes, then we get the optimum solution. Okay. So these are the steps in formation of an LPP. So as I said, you do not have any problems of solving an LPP. Very clearly in the syllabus they have given, only formation of LPP is there, solving is not there. At the most, they may ask you to have a dual problem. So dual problem, what is a dual problem? I'll tell you as we come to it. Okay. So this is what we have got. Now, for example, let us take small case. We'll start with question number 1. This is a small example which we are starting with, a typical example where we are just learning. The objective here is to learn as to how to form an LPP. So the method that I'm using over here is not actually the method that we are going to solve. We'll have a slight variation, but still I will try to tell you as to what should be the method of solving the problem. Okay, let us come to the question. First question, question number 1. A manufacturer is making two products A and B. Two raw materials R1 and R2 are required to make these two products. Each unit of each unit of A requires 1 unit of R1 and 3 units of R2. And each unit of B requires 1 unit of R1 and 2 units of R2. The manufacturer has 5 units of R1 and 12 units of R2 available. Manufacturer makes a profit of 6 rupees per unit of product A sold and 5 rupees per unit of product B sold. Formulate an LPP. Now, the first thing that we have to do is understand the problem. Understand what is given to us, what is going to be the variables that I will define, and then we will try to form an LPP. Okay. Now, for our understanding, either we can prepare a small table or we can prepare a small diagram for our understanding, either in the rough or you can show it in the fair also, no issue. But we have to first try to understand what is given to us and how it can be solved. Okay. Now, first what I will do is, since it's my very first beginning problem, don't write anything, just pay attention. Now, this is how I teach the students first time when they are learning LPP. Two raw materials, R1, R2. Two products, A and B. And outside here, I write profit. So I tell the students that if you don't understand the problem, draw a figure like this. That two products require two raw materials. So the two products are A and B, and the two raw materials are R1 and R2. So each unit of A requires 1 unit of R1, okay, 1 unit of R1 and 3 units of R2. So A requires 1 unit of R1 and 3 units of R2. Each unit of B requires 1 unit of R1 and 2 units of R2. Okay. So 1 unit of A requires 1 unit of R1 and 3 units of R2. 1 unit of B requires 1 unit of R1 and 2 units of R2. Now they have said manufacturer has total 5 units of R1. 5 units of R1. So whatever amount of R1 we are using, we cannot go beyond 5. And 12 units of R2, that means total number of units of raw material 2 is 12. At the same time, 1 unit of product A when I sell, I get a profit of 6 rupees per unit. Okay, 6 rupees per unit. And when I sell 1 unit of B, I will get a profit of 5 rupees per unit. So this is my problem actually, which I put in a diagrammatic form. Now what I have to do, as I said, my first step will be defining the variables. So how many units of A and B should be produced? That is my problem. Because I cannot produce unlimited quantity of A and unlimited quantity of B. Why I cannot produce unlimited quantity? Because I've got only 5 units of raw material 1 and 12 units of raw material 2. So with that, I have to produce as much as possible with the objective of maximizing the profits. So the profit problem is there. It is a problem of maximizing the profits. So objective function is maximization. Profit, if it is given, it is always a maximization problem. Cost, if it is given, it is always a minimization problem. Okay. So first draw this figure. Then I will tell you what is to be done. This is only first lecture, first problem I'm drawing these figures and all. Otherwise, you can draw a table also. Sometimes you will need to draw a table instead of this figure. Done? Okay. Now, as I said, first step is always defining the variables. I want to know how many units of A and how many units of B should be produced. So I will say, let X1 be number of units of product A manufactured, and let X2 be the number of units of product B manufactured. See, in LPP, since the question will be only for formulating an LPP, all your statements carry marks in the examination. All your explanations carry marks in the examination. Okay, so let us write down. We have to find number of units of product A and B. Number of units of product A and product B to be manufactured. With limited resources. Of R1 and R2, and with the objective of maximizing profits. Okay. Then we define the variables. Let X1 be number of units of Product A manufactured. Let X2 be number of units of product B manufactured. Okay. Objective function. Next line, right? Objective function. The objective is to maximize profits. Objective is to maximize profits. Profit is given by Z is equal to I want to have my total profit will be made up of number of units of A into 6 rupees per unit plus number of units of B into 5 rupees per unit, which means 6x1 plus 5x2. This is my profit function. So profit is given by Z is equal to 6x1 plus 5x2. Therefore, what is the objective function then? Maximize Z is equal to 6x1 plus 5x2. This is my objective function. Then total number of units of raw material R1 is 5 and total number of units of raw material R2 is 12. Therefore, constraints can be given as one unit of R1 for A, and A, how many units we are producing? X number of units, X1 units, and X2 units of B. So 1 into X1 plus 1 into X2 should be equal to or less than 5. Maximum 5. So it can be 5 or less than 5. So 1 X1 plus 1 X2, meaning X1 plus X2, should be less than or equal to 5. Total quantity of raw materials used. And for a product B, this is for product A. This is for raw material A, sorry. Raw material R1. And for raw material R2, it will be 3 into x1 plus 2 into x2 should be equal to or less than 12. 3 into x1 plus 2 into x2 should be less than or equal to 12. This is the constraint for raw material R2. Now, common for every problem is that you have defined your x1 and x2 as number of units of product A and B. Number of units. So, number of units can never be negative. Number of units can never be negative. So, number of units will be either equal to 0 or it will be more than 0, positive. It can never be negative. So, my non-negativity constraints, they are called as non-negativity constraints. So, next line, right? Non-negativity constraints. And this will be common for all problems. x1, comma, x2 greater than or equal to 0. Greater than or equal to 0. Okay. Now all these things you have to put together and formulate an LPP. We have not yet formulated an LPP. We have just done the explanation. So formulation of LPP. Means what? You write the objective function. Maximize z is equal to 6x plus 6x1 plus 5x2 subject to. How do you write the constraints? You have to use the word subject to. You don't use the word subject to, you are gone. You are losing marks. Subject to constraints. And what are the constraints? Subject to x1 plus x2 less than or equal to 5, 3x1 plus 2x2 less than or equal to 12, and x1 comma x2 greater than or equal to 0. This is called as formulation of an LPP, where you are writing the objective function, maximization or a minimization, subject to. The word subject to is important. You write any other word, it is of no use. Subject to, and you write the constraints one below the other. So what are the features that you have to note over here? The features that you have to note over here is that, very important feature, is that first of all, there will be a non-negativity constraint in every problem, where the variables that you have defined are such that they cannot be negative. So it will be number of books or number of products that you are manufacturing, okay, or number of food items that you are delivering. So something like that, which cannot be negative in nature. You cannot have -5 books sold or a -5 products sold. So it will be always a non-negativity constraint. Okay. Now, second thing that you note is that what I am telling you now, that you have to keep your eyes open. If the function is to maximize, normally in 95 to 99% of the cases, your constraints will be always less than or equal to. If your function is to maximize, then your constraints will always be less than or equal to. Whereas, if it is to minimize, then your constraints will be normally more than or equal. So there may be situations where you don't have You have the maximization function, but then you are having a greater than function for constraints. So you'll have to convert them. How to convert? We'll see if it is required actually. So this is the point that you have to remember. If it is a maximization problem, your constraints will be always less than or equal to. If it is a minimization problem, your constraints will always be more than or equal to. Okay? Non-negativity constraint remains the same for all problems. So whatever variables you have defined, suppose you have defined 4 variables, x1, x2, x3, x4. Then at the end you have to write all the 4 variables, x1, x2, x3, x4, greater than or equal to 0. Okay? So this was your first problem. Let us come to second problem. Now I have collected different problems of different types. Instead of doing the same type of problems, I have taken different type of problems, different situations, so that we understand various circumstances in which we have to form a LPP, because anything can be asked.
Sir, in this question, if we are progressing with the answer for calculating the actual values of the x1 and x2.
No, that is what I said.
So,
at the very beginning, I said that the solving of an LPP is not there.
No, sir. I'm just asking, how do we proceed? Is it a graph?
No.
Do we take a graph and take the highest point?
No, we will have to, if they have asked you to solve by graph, then only use the graph method. If not, then we have to make use of simplex method.
No, I'm asking just to know because, okay.
No. Even with the graph, you will not be able to get the exact points. You will get the intersection points, you will get the common points, but the exact points you will not be able to get. Solution can be normally done with the help of simplex method.
Okay.
Okay. Yeah. What we can do is, at the end of the topic, we can take up one problem of your examination only, of the past paper, that is prior to 2016 syllabus, whatever syllabus was there. Of that, we can take one examination problem and see simplex method how to solve. Because normally the questions are solved with the help of simplex method.
Okay.
Only when they specifically mention graphical method, then we can make use of graph. Right?
Oh.
Question 2. A diet-conscious housewife wishes to ensure certain minimum intake of vitamins A, B, and C for the family. The minimum daily needs quantity-wise of the vitamins A, B, and C are 30, 20, and 16 units respectively. For the supply of these minimum requirements, the housewife relies on 2 fresh foods. The first one provides 7, 5, and 2 units of the 3 vitamins per gram, and the second one provides 2, 4, and 8 units respectively per gram of the foodstuff respectively. The first foodstuff costs 3 rupees per gram and the second 2 rupees per gram. The problem is, how many grams of each foodstuff should the housewife buy every day to keep her food bill as low as possible? Formulate the LPP. Okay, so what we will try to do is, we'll try to get the foodstuff by defining the foodstuffs first, and then we'll try to, that is, first form a table. As I told you, in some problems you'll require a table to understand what is given, and that is required to be drawn in the examination. Then we will start defining the variables, then the objective function, then the constraints. Okay, a rough table is required to be drawn with all these details. So what we will do is, let the foodstuff, let the 2 foodstuff be X and Y. Okay. So if I have vitamins A, B, and C, the cost will be foodstuff X and Y. Okay. Let us try to get this table. Then we'll define the variables. A, B, C vertically, X and Y horizontally. Now, what they have given us, the minimum daily needs of the vitamins A, B, and C are 30, 20, and 16. So this total, what is here, this total of vitamins A, B, and C should be 30, 20, and 16. Total vitamins. Now, for the supply of these minimum requirements, the housewife relies on two fresh foods. And those two fresh foods are X and Y. The first one, let us call it as X, provides 7, 5, and 2 units of the three vitamins. X provides 7, 5, and 2 units. And the second one, let us call it as Y, provides 2, 4, and 8 units. 2, 4, and 8 units of the three vitamins. The first foodstuff, that is X, is costing me 3 rupees per gram. This is the cost. 3 rupees per gram. And the second one provides, and the second one is costing me 2 rupees per gram. That is why it's costing me 2 rupees per gram. Okay, what is the question? Problem is how many grams of each foodstuff should the housewife buy every day? So I say let X1 and X2 be the number of the first product and the second product X and Y purchased. Okay, let X1 and X2, defining the variables. Let X1 be number of units of, what are they called? Fresh food. Of food X purchased. Let X2 be number of units of food Y purchased. So defining the variables. So now objective function, just like what we have done over here. Okay, you have defined the variables. Now we have the objective function. Foodstuff X and Y need to be purchased. Need to be purchased in such quantities. In such quantities that their total cost is minimum. Cost is given by Cost is given by. What did I say? Let x1 be number of units of x and x2 be number of units of y. So if I'm purchasing x1 number of units of x, so x1 into 3 plus x2 into 2 should be minimum. So I say cost is given by z is equal to 3 into x1 plus 2 into x2. Therefore, objective function will be minimize z is equal to 3x1 plus 2x2. Okay. Now, if you look at the question, they have said the minimum daily needs of vitamins A, B, and C are 30, 20, and 16. So these figures of 30, 20, and 16 are the minimum requirements of the three vitamins. So that means on the consumption of the two food items, vitamin A should be minimum 30 units, meaning 30 units or more is likely. By consuming B, that is by consuming the two products, vitamin B should be minimum 20 or more, and vitamin C should be minimum 16 or more. Okay, so I say next line, right? Same as we are doing here. After objective function, we write the constraints. As the minimum requirement of vitamins A, B, and C are 30, 20, and 16. The constraints can be expressed as follows. Constraint functions. First constraint, 7 into x1 plus 2 into x2 should be greater than or equal to 30. 7x1 plus 2 into x2 should be greater than or equal to 30. This is for vitamin A. Okay. So in bracket, you see that you are writing what is the constraint for. Then for vitamin B, 5x1 plus 4x2. 5x1 plus 4x2 greater than or equal to 20. That is for vitamin B. And last one, it is 2x1 plus 8x2. 2x1 plus 8x2 greater than or equal to 16. Vitamin C. Non-negativity constraints. Non-negativity constraints. x1, x2 greater than or equal to 0. So now put all together in the form of LPP. Don't leave the problem like this because you have not formed the LPP as such. LPP formulation always means objective function subject to. That word subject to has to come. Okay? So write down. Formation of LPP. Minimize. Objective function is to minimize now. Minimize. Z is equal to 3x1 plus 2x2. Subject to 7x1 plus 2x2 greater than or equal to 30. This is your vitamin A function. 5x1 plus 4x2 greater than or equal to 20. And 2x1 plus 8x2 greater than or equal to 60. x1 comma x2 greater than or equal to 0. Question number 3. A firm makes two types of furniture, chairs and tables. The contribution for each product as calculated by the accounting department is 20 rupees per chair and 30 rupees per table. Both products are processed on 3 machines, M1, M2 and M3. The time required by each product in hours and the total time available per week on each machine are as follows. So they have given you the total number of hours available for machine 1 as 36, machine 2 50, machine 3 60. And number of hours required on each machine by the chairs and tables are also given to you. How should the manufacturer schedule his production in order to maximize the contribution? Formulate the problem as an LPP. Cancel that unsolved part because solving is not there. So what I will assume is now that since they have given us contribution as 20 and 30, contribution is profit. So objective is to maximize. It's a maximization problem. So I'll start by saying let x1 be the number of chairs and x2 be the number of tables. Okay. So we have to find out to maximize the profit, how many chairs and how many tables should be manufactured. Okay. So they have already given us the table. No need to prepare the table again. So we'll directly start with defining the variables. Let x1 be number of chairs produced. X2B, number of tables produced. Objective function. The question has been framed as how should the manufacturer schedule his production in order to maximize the contribution. Okay, so write down. The chairs and tables should be produced in such quantities, as will maximize the contribution, Contribution is given as Z is equal to, contribution is 20 per share, so 20 into X1, and 30 per table, so 30 into X2. So what is a objective function? Maximize. Z is equal to 20x1 plus 30x2. Okay, next line write. This is a maximization function, objective function. Next line write. We cannot produce as many chairs and tables as required. As many chairs and tables as required. Because machine hours available is restricted. Machine hours available is restricted. So for machine M1, maximum 36 hours are available, where 3 hours are required per chair and 3 hours are required per table. So if I'm producing X1 number of chairs and X2 number of tables, my first objective function, my first restriction will be, it is constraint function. Three X1 plus 3x2 less than or equal to, always remember, if objective function is maximized, this is less than or equal to. I've got maximum 36 hours. Okay, so this is of machine M1. Second machine 5x2, 5x1 plus 2x2 less than or equal to 50. Machine M2. And third machine is 2x1 plus 6x2 less than or equal to 60. Formation of LPP.
Non-negativity constant, sir.
Yeah, sorry. Non-negativity constraints. x1, x2 greater than or equal to 0. Non-negativity constraints. So formation of LPP, maximize Z is equal to 30x1 plus 30x2, sorry, 20x1 plus 30x2, subject to 3x1 plus 3x2 less than or equal to 36. 5x1 plus 2x2 less than or equal to 50. 2x1 plus 6x2 less than or equal to 60. x1, x2 greater than or equal to 0. Okay. Now we'll take up some different type of question. Question number 4. And this question actually is a CA final problem. CA final problem, which is LPP plus your other items coming into picture. Combined problem. So you can have this type of question also. Because decision making is also there, and LPP as well as marginal costing both are there. Okay, so let us see how to solve. A company manufactures two products X and Y. Each product passes through two departments A and B before it becomes a finished product. The data provided is maximum sales potential in units 7,400 and 10,000. Product unit data is given, that is per unit figures. Machine hours, selling price per unit is 90 and 80. Machine hours per unit, department A, it is at the rate of 40 rupees per hour, 0.5 hours per unit and 0.3 hours per unit. Department B at the rate of 60 rupees per hour, 0.40 hours per unit and 0.45 hours per unit. Machine capacity of department A is 3,400 hours, so that is your first constraint. And department B is 3,640 hours. Maximum quantity of direct materials available is 17,000 kgs. Each product requires 2 kgs of direct materials. The purchase price of direct material is 5 rupees per kg. Now, what is the question? They're saying prepare statement showing limiting factor. Prepare statement showing limiting factor. Second is prepare statement of ranking of products. And third is prepare or formulate an LPP to find the optimum mix of products that will lead to maximum profits. So it is a combination of your marginal costing plus your decision making, LPP. Okay, so let us start with the first part, that is preparing statement showing limiting factor. Particulars, materials, department A hours, department B hours. Okay, starting with required quantity of X. Required for X. How much materials are required for X? Tell me. How much materials are required for X? 7,400 units you are going to sell. And each unit of each unit of X, each product requires 2 kgs of direct materials. So 7,400 into 2, that is 14,800 kgs. 14,800 kgs. Okay, so how did I get this? It is 7,400 kgs units at the rate of 2 kgs per unit. Required Y, 10,000 units at 2 rupees at 2 kgs per unit. So it will be 20,000. Department A hours, 0.5 hours per unit. So 7,400. 7,400 into 0.5. 7,400 into 0.5. That is 37, 3,700 hours. And for Y, it is 0.3 hours. So it is 10,000 into 0.3 hours. That is 3,000 hours. Same way for department B, 0.4 into 7,400, 2,960 hours. and 0.45 into 10,000 units. That is 4,500 hours. Total requirement 34,800 kgs, 6,700 hours, 7,460 hours. Available resources. Material is available to the extent direct materials available is maximum 17,000 kgs. Maximum 17,000 kgs. Department A, maximum machine capacity of Department A, maximum 3,400 hours. And machine B, Department B is 3,640 hours. So there is a shortage of 17,800 kgs of raw material, 3,300 hours of machine hours of Department A, and 3,820 machine hours of Department B. So now why they have asked you to prepare statement showing limiting factor? Because they want you to point out that look here, three resources are there, materials, machine hours of A, machine hours of B, and all three of them are limiting factors because all three are in short supply. So below the statement you write, from the above, we can conclude that all the three resources are limiting factors. So that is the objective of asking you to prepare the statement of limiting factors. Second statement that they have asked for is prepare statement of ranking of products. Now, again, we have done earlier also statement of ranking of products, but we have done where the limiting factor was only one, where labor hours were the limiting factor or machine hours were the limiting factor. Only one factor was limiting. So we calculated contribution per unit first and then contribution per unit of limiting factor. So only one ranking was there. So since we are having three limiting factors, we will have three rankings done. One on the basis of materials, one on the basis of machine hours of Department A, and one on the basis of machine hours of Department B. That is why They have asked you to prepare statement of ranking of products. Because if you rank the products on the basis of one particular factor and you don't write the other two, your marks are gone. Because normally we are used to calculating only one ranking on the basis of one limiting factor. Now we are having three limiting factors. Keep that in mind. Okay. So let us prepare statement of ranking. Statement showing ranking of products. Particulars in two columns, product X, product Y. Starting with sales per unit, selling price per unit. Selling price per unit is 90 and 80. Less. Direct material. Per unit. How much is direct material cost per unit? Read the question. Tell me what is the direct material cost per unit?
10 rupees.
10 rupees. 5 kgs are required per unit of a product. 2 kgs are required per unit of a product, and each kg is costing 5 rupees. So 2 into 5, 10 rupees. Department A. Machine hour cost. ₹40 per hour, and per unit it is 0.5 hours. So 40 into 0.5 is 20, and 40 into 0.3 is 12. Department B, machine hour cost. 60 into 0.4, that is 24. 60 into 0.45, 27. Contribution per kg or per unit, you can say. Per unit. 40, 50, 54, 60, 90. That is 31. Okay. Now, 3 rankings we have to do. So 3 contributions are required. Contribution per kg of raw material, contribution per hour of department A and contribution per hour of department B. So we'll do one at a time. Right, number one, contribution per kg of raw material. Per kg of raw material. 1 unit requires 2 kgs. So 36 divided by 2 is 18. And 31 divided by 2 is 15.5. 2 kgs are required per unit. So per kg, 36 divided by 2. And for Y, it is 31 divided by 2. So what is the rank over here? First, I will produce product X, then I will produce product Y. Second, contribution per hour of department X, of department A, sorry. Per unit, department A requires 0.5 hours per unit. 0.5 hours. So 0.5 into 36. Sorry, 36 divided by 0.5. 36 divided by 0.5. 72. And for product Y, it is 0.3. So 31 divided by 0.3 is 103.33. So rank over here. Product Y will get first rank, second rank. Contribution per hour. Department B. Thirty-six divided by 0.4 is 90. And 31 divided by 0.45. 68.89. First answer. This is a statement showing the ranking of products. Now for formulation of LPP. Defining the variables. So I say let X1 and X2 be the quantities of product X and product Y manufactured. Let X1 be number of units of product X manufactured. Let X2 be number of units of product Y manufactured. What do we have to do? Maximize the profits or minimize the cost? What is the question? Maximize the profits or minimize the cost? Dear students, you are asked to answer. Maximize the profit or minimize the cost? What is the question? Yes, Ashok, what is the question?
Minimize the cost, sir.
Yes, Ashok.
Sir, please share the questions in screen. Please share the question, sir, on screen.
You have not downloaded the question.
Maximum profit.
Maximize the profits. So, question is of maximization. So write down. Objective function. We have to find that product mix of X and Y which will help us to maximize the profits. Profit function is given as Z is equal to contribution per unit is 36. So 36 into X1 plus 31 into X2. 36 into X1 plus 31 into X2. Maximum Z is equal to, maximum Z is equal to 36 X1 plus 31 X2. Okay, next line write. In the given case, materials, labor, machine hours in department A and B are the constraints. So if you take the question now, we are told that maximum direct materials we are having 17,000 kgs and we require 2 kgs for each of the products per unit. So I will have 2 into x1 plus 2 into x2 should be less than or equal to 17,000. This is for material. Then I'm given that department A, we are having maximum 3,400 hours. So 0.5 into x1 plus 0.3 into x2 less than or equal to 3,400. Last one, department B, 0.4 x1 plus 0.45 x2 less than or equal to 3,640. Tell me what are the other constraints? What are the other constraints in the problem? Yes, Prasad. What are the other constraints in the problem?
Maximum cells.
Maximum sales. So how do we write this now? Maximum sales of X is 7,400 and maximum sales of Y can be 10,000. So that is a maximum demand. So I will say X1 is less than or equal to X1 is less than or equal to maximum of X that I can sell is 7,400. Maximum of X2 that I can sell is 10,000. Demand for X, demand of Y. Non-negativity constraints. X1, X2 greater than or equal to 0. So let us write down entire LPP problem. Formulation of LPP. Maximize Z is equal to 36x1 plus 31x2 subject to 2x1 plus 2x2 less than or equal to 17,000. 0.5x1 plus 0.3 x2 less than or equal to 3,400. 0.4 x1 plus 0.45 x2 less than or equal to 3,640. Less than or equal to 7,400. X2 less than or equal to 10,000. Any difficulty? We'll take a small break of 5 minutes. Let's start with question number 5 now. Again, a slightly different type of question. We'll be having something different in each question now because the nature of questions are going to be different. Question 5. The owner of fancy goods is interested to determine how many advertisements to release in the selected 3 magazines, A, B, and C. His main purpose is to advertise in such a way that total exposure to principal buyers of his goods is maximized. Percentage of readers for each magazine are known. Exposure in any particular magazine is the number of advertisements released multiplied by the number of principal buyers. The following data is available. They are given the readers for each magazine, 1,60,000 and 40,000. Principal buyers, 20%, 15% and 8%. Cost per advertisement, 8, 6 and 5,000. Budgeted amount is at the most 1 lakh for the advertisement. So that is a restraint. Owner has already decided that magazine A should not have more than 15 advertisements. And B and C each gets at least 8 advertisements. Formulate an LPP. Let us start with defining the variables. What will be the variables here? X1, X2 and X3. What will that be? Will it be number of readers? Will it be number of advertisements? Will it be the cost of the advertisements? What will it be?
What was the question, sir?
What will be the variables X1, X2, X3 defined as? Will it be the number of readers, number of principal buyers, Cost per advertisement, number of advertisements, what will it be?
Principal buyer.
No, principal bias is already given. So number of x1, x2 and x3, the three variables will be the required number of insertions or advertisements in each magazine. Magazine A, B and C. Okay, number of advertisements. So let us write down. Question 5. Let x1 be number of insertions in magazine A. X2 be number of insertions in magazine B. Okay, tell me the objective function here. What should be the objective? What should be the objective function? Read the question. What should be the objective function? Maximization, minimization, maximization of what? Advertisements, minimization of cost. What should it be?
Minimization of cost.
Where it is given? Which part of the problem says that we have to minimize the cost? What has been given? What is the main purpose?
Principal buyers of the purchase man.
Advertise in such a way that total exposure to principal buyers.
Principal
is
buyers of
maximized.
purchase.
Yes. So objective function is to maximize the number of principal buyers. Okay. So neither it is a cost, nor it is a revenue, nor it is a profit. Here we are concerned with maximization of principal buyers, exposure to principal buyers. Okay. So let us write down. Advertisement insertions. Advertisement insertions should be done with the objective of maximization of exposure to principal buyers. Maximization of exposure to principal buyers. exposure to principal buyers is given as Z is equal to, for a magazine A, 20% of 1 lakh. For a magazine B, 15% of 60,000. And for magazine C, 8% of 40,000. So it is 20% of 1 lakh into X1 plus 15% of 60,000 into X2 plus 8% of 40,000 into X3. So I can reduce this to 20,000 X1 plus 15% of 60,000 is 9,000. 9,000 X2 plus 3,200 X3. So objective function is maximize Z is equal to 20,000 X1 plus 9,000 X2 plus 3,200 X3. So objective function we have got. Now for the restraints or the constraints. Magazine A should not have more than 15 advertisements. And B and C each gets at least 8 advertisements. So how do we write this now? Number of advertisements in each magazines are restricted. So let us write down the number of advertisements in each magazine are pre-decided. And fixed. So they have said that not more than 15 advertisements in magazine A. So X1 should not be more than 15. So that means less than or equal to 15. Magazine A. X2 should not be more than 8. No, sorry. B and C each gets at least 8 advertisements. So X2 is greater than or equal to 8. At least means minimum. X3 is greater than or equal to 8. Non-negativity constraints. X1, X2, X3 greater than or equal to 0. So formulation of LPP. maximize Z is equal to 20,000 X1 plus 9,000 X2 plus 3,200 X3 subject to one minute. There is one more constraint. Budgeted amount is at the most 1 lakh. So how do we calculate the budgeted amount? This is of 3 magazines. There is one more. How do we calculate the budgeted amount? Cost per advertisement is 8,000, 6,000 and 5,000. So 8,000 into X1 plus 6,000 into X2 plus 5,000 into X3 should be less than or equal to 1 lakh. This is for the cost or the budget you can get. So there are 4 constraints and 1 non-negativity constraint. So subject to X1 less than or equal to 50, magazine A, X2 greater than or equal to 8 for magazine B, X3 greater than or equal to 8 for magazine C, and 8,000 X1 plus 6,000 X2 plus 5,000 X3 less than or equal to 1 lakh. This is the cost or budget constraint. If I had to solve this now, what I would have to do is X2 and X3, I would have to change the signs. How do we change the signs? Any idea? How do we change the signs in an equation? We multiply by -1 on each side. So if I have to solve the equation, I will have to first bring them in the standard format. Multiply second and third equation by -1. So minus X2 will be less than or equal to 8 and minus X3 will be less than or equal to -8. So I will have to multiply -1 on either side to convert the greater than into less than equal to sign. Question number 6. I want you to tell me the final answer just now without my help. Very simple. A firm manufactures 2 products, each of which passes through 2 departments, D1 and D2. The hourly requirements per unit of each product in each department, the weekly capacities in each department, selling price per unit, labor cost per unit, and raw material cost per unit are summarized as follows. Department 1, 3, 2, and 120. 120 is the weekly capacity. Department 2, weekly capacity 260. Selling price per unit, labor cost per unit, and raw material cost per unit is given. Problem is to determine the number of units to be produced of each product so as to maximize total contribution to profit. Formulate an LPP. So do it and tell me.
objective function is 5x1 plus 6x2. Z is equals to 5x1 plus 6x2.
That is the objective function. You have not told me whether it is maximize or minimize.
Maximize. Maximize Z is equals to.
Okay. Maximize Z is equal to 5x1 plus 6x2. Correct.
Subject to 3x1 plus 2x2 is less than or equal to 120. 4x1 plus 6x2 is less than or equal to 620. And non-negative constraints.
620 or 260?
Sorry, 260.
Okay. And then non-negativity constraints x1, x2 greater than or equal to 0. Correct. So objective function, we are having Z is equal to 5x1 plus 6x2. That is, you have to calculate the contribution from these three items. 25 minus 20, so that will be 5 rupees here. And 30 minus 24, that will be 6 rupees here. So number of units of A will be x1, number of units of B will be x2. So 5x1 plus 6x2 should be maximized. And then for each department, you are having the constraints. So 3x1 plus 2x2 less than or equal to 120. 4x1 plus 6x2 less than or equal to 260. Okay. So we'll stop here for today. Tomorrow we'll continue in the evening, 6:30. We'll complete this topic tomorrow. LPP will be finished tomorrow. But tomorrow we'll have some different type of questions. We'll have some questions on financials also. That is mutual fund company. I've got one question. Then we'll take up examination problems which have been asked in the past papers for tomorrow. Okay. So tomorrow 6:30, we'll continue with LPP. We'll finish with LPP.
Thank you, sir.
Thank you.
Yes, sir. Bye. Good night.
Good night.
Bye. Good night, sir.